A local arena has 10 applicants interested in working in the snack bar. How many ways can 4 applicants be chosen? Well, does order matter? If they hire 4 people and like, oh, we don't like the 4 we hired, so we're going to hire the same 4 people in a different order? No, order does not matter. So the first thing you're going to have to start doing now with questions is first ask yourself, does the order matter or not? Obviously, this is part of your combinations notes, so it's kind of giving you a hint that it's about combinations. But when you have it on a test or a quiz or in your homework later, you're going to have to make that decision. The order doesn't matter, so this is a combination. We have 10 people, and we need to choose 4 of them. Now, according to your formula sheet, this would be 10 factorial over, and this formula you will memorize because it's easy enough to do. It's going to be 10 factorial over, and on the bottom you'll have the 4 factorial, and then whatever number adds back up to the top number. So 10 factorial over 4 factorial, 6 factorial. And if you wanted to simplify this by hand, remember we expand the bigger one until we get to a number on the bottom, which is 6 factorial. And if I expand 4 times 3 times 2 times 1, those 6 factorials will simplify. 4 times 2 is 8. So that would simplify there. And then I could also simplify 9 over 3 is the same as 3 over 1. What am I left with? Everything on the bottom simplified. And on the top, I have 3 times 7 times 10, 210. In part B, they decide, you know what? We need more people working in the snack bar. We're going to hire 6 people. Right? Some businesses hire more part-time instead of full-time because there's rules about how many breaks a full-time person gets and how many breaks a half-time, right? Is that true? Part-time you don't get as many breaks? So, and so sometimes businesses take advantage of that and say if we hire part-time people, we can pay the same amount of money, but we don't have to give them breaks. And then that's better for our business. So 10 choose 6. Well, if I go to the formula, what do you notice? It's exactly the same. And it's important to understand why it's exactly the same. Probably a really good way to visualize this if I pretend these 10 people are 10 different cards. 1, 2, 3, 4, 5, 6, 7, 8. Part of the combinations formula has that extra number. The 6 factorial is under there to divide out the repetition. The 4 factorial is part of the permutations formula. Okay, so if I have 10 different people as represented by these 10 cards, every time I make a group of 4, I also make a group of 6. So every unique group of 4, where the order doesn't matter, leaves me with a unique group of 6. So does it make sense that choosing 4 is the same as choosing 6? Because every time you choose 4, you are left with 6 people who didn't get the job. And every time you choose 6, you're left with 4 people who didn't get a job. So if I have 52 cards, how many ways can I choose 1 card? This isn't hard. This is not tricky. If I have 52 cards and I choose 1, how many different ways could I do that? 52 different ways. It's a little bit harder to imagine if I have 52 cards and I want to choose a group of 51 of them where the order doesn't matter. How many ways can I do that? 52 ways. Because choosing 51 cards where the order doesn't matter is the same as choosing 1 card. Does that make sense? If there's 52 different ways I can choose 1 card, there will be 52 different ways I could choose 51 cards if the order doesn't matter. Oh, we're just getting started. All right. All right, questions for this one are 8 and 10.